So this is going to be a very quick and basic video about randomization with constraints. And in this video, I will just create a class which will have a variable, and that variable will be declared as a rand so that it can be randomized. And it will also have some sets of constraints. And then on the test bench, I will use immediate assertion to check if the randomization fails or not. So let's begin. So first I will declare a class. I will call it packet. And then I will mention the variable which I want to randomize. I want the width to be 32 bits. And I will call it S. So to make it sure that this variable could be randomized, you have to use a keyword rand before the data type. So this ensures that this variable could be randomized. So it is that simple. So I will save the code and I will just begin with the test bench. So I will declare the handle for the class packet. I will call it P. Then I will begin with my initial block. And inside my initial block, I will create an object for the handle P. Then I will write P dot randomize. So this ensures that all the variables inside the class packet which are declared with the keyword rand will get randomized. So let's do it. And then I will display whatever value is received using the $display system task. And just to refer to my variable s, I need to first write the handle. Then using the dot method, I will access the variable s. So it is that simple. So let's check for any compilation errors. Okay, it's fine. So let's go ahead and run the simulation. So as you can see it right here that we are getting a random value, and it is quite oblivious because it is very random. So you could just go ahead and put a constraint for that just a second, it should be p.s. So you could just go ahead and put a constraint, and you can mention a range, and inside that range the value will appear. So for example, here in this randomized class, what I will do first, uh, so to put a constraint, you have to use the keyword constraint, and then it should be followed by curly brackets. So it is very similar to beans, but in beans you have to also use the equals to. So you don't have to use equals to here, and you also have to label your constraint. So here I will label it s underscore c, since it is focusing towards the variable s, and it is user defined. You can name it whatever you want. So inside this, I will put some constraints. So let's say I want the value to be greater than 10, and it should be less than 15. So it should be between 10 and 15. So it could be 11, it could be 12, 13, and 14. So after putting these constraints, let's just go ahead and run the simulation for one more time. Just making it sure that I have saved the code. All right, we have no errors, so let's run the simulation. So as you can see it right here, that this time we are getting the value within our constraint range. We put a particular constraint so that it could be limited between uh, an integer value of 10 and 15. So just like that, you could put constraint, and constraint is a very powerful thing. So together they are called constraint randomization, and you could do a lots of things. You could just write a for loop inside this, and you can constrain this to make it byte aligned and word aligned, etc. So I would like to add one more extra thing to my code, and that will make it sure that whether there is anything wrong within the constraint you are mentioning or not. So you can do that just by writing the uh, assert. So I am just covering this inside an immediate assertion, and I could just write assert, and if the assertion fails, then you could just write else, and you could just generate an error. And inside this error, uh, you could just write any string message you want. I will just write packet randomize fail. So the randomization basically failed. So let's save the code, and let's try to create a condition in which the randomization will fail and the assertion will occur. So for this, what I will do that uh, my constraint clearly specifies that the value of s should be greater than 10 and less than 15. So what I will do, I will force it to be less than 9. So this is kind of, I mean, it is opposing the former constraint that it is greater than 10. Okay, but if it is greater than the 10, then how can it how can it be less than 9? So if you use immediate assertion and cover it for the randomized method, it will just check whether there are any faults specifically inside the constraints, and then it can generate an error if you have mentioned right here. And even if you don't mention it right here, the assertion will fail and it will be displayed in the terminal. So I will just save the code and I will try to run the code. All right, so let's run the simulation. So as you can see it right here that we are getting error which we have mentioned in the assertion check, and it is also showing that the randomization failed due to conflicts between the following constraints. So using this you can clearly show that whether there is any fault with your constraints or not. So regardless of your assertion, this failed or illegal constraint message will still get generated during the runtime, but still it will not count toward any error. So using the assertion, you could just make this count it as an error and it could be specifically printed. So that's all about a very basic class on creating a class with randomized properties and using the randomized method to randomize those properties, and also using the concept of constraint to constrain the value between a certain range. Thank you so much.